IE, and I'm going to show you the other one. Okay, so bear with me. So IE, one of the point will be over here, stress mean. Okay, one of the point over here. So one of the circle, okay, will touch stress mean. Okay, so now I'm going to draw a straight line. Okay, I'm going to draw a straight line from here to here now. Right. So this will determine one of the circle. Okay, I repeat again. This will determine one of the small circle. Okay, one of the small circle. So before I go on, let me highlight the criteria. Okay, so the criteria states that stress mean and tau max has to control. Okay, so i.e., if I'm going to draw one of the mole circle, one of the mole circle will look like this. One of the circle will look like this. Okay. So this is one of the circle. Okay. So it touches stress mean. Okay. It also have to touch Z because Z point, this point is fixed. Okay. This point, regardless of any situation, is fixed already. So now we have to draw two more circles inside there. Okay. We have to draw two more circles. Now, did I go with you guys the rules of the circle? Yes or no? Could you all remember? Did we do the rules of the circle? Hello?
In this class.
We did, right?
Not here. We
Okay.
didn't see.
Okay, so so we did not, we gotta do down here, my bad. Okay, so the rules of the circle. Okay, let's look at quickly at the rules. I thought I did, but I was wrong. Thank you for telling me. So if we look at the rules of the circle, okay, before I go on, can you answer me how many points do we need to exactly locate the location of a circle in 2D? How many points do we need? 3 or 2 points? Anyone?
3.
3 points. Anyone else?
I want to say 2.
You're gonna say 2? Okay. I'll show you the rules of the circle. Then we make a decision. Okay, so let's look at the rules of the circle. Now in 2D space, it is 2. But some of you will think of the GPS, right? To triangulate, they call it triangulate something, right? To triangulate something in 3D space, you need 3 points. Okay. In 2D, you only need 2 points. Okay. And some of you, how is that possible? It's through the rules of the circle. So if we were to draw the rules of the circle, so this is a circle. Look, 2, 4, 6. Okay. So 6, 6. Okay. So this is the circle. That's a center point. And if you're at home now, do this together with me, okay, on your computer or whatever. You draw a straight line across the circle, okay, across the center of the circle. You label this at point A, and you label this at point B, okay. So now, if I'm going to pick, I deliberately pick a point over here, okay. I deliberately pick a point over here. So this is my point D, okay. So if I deliberately pick a point over here, okay. So if you look at the grid line that I have, right? The grid line that I have, you realize that this is automatically how many degrees, anyone? 90 degrees. Am I right? Right, this is spot on 90 degrees. That's what we call the rules of the circle. Okay. So now if I pick another point down here, some of you say, hey, that is a trick. Point C down here. And I will happen to draw another triangle. Okay, so from point A to point C, right? And then C to point B, right? What you realize that this is also 90 degrees. Okay. Right? Okay, so now, knowing this rule now, I come back here. Right? So if I were to now, so we have 2 points, yes or no? So I'm going to copy this line. Right? I'm going to paste. And then I'm going to rotate this line by 90 degrees. Okay. So this point over here is my what? diameter of my circle? Yes or no? Because this is 90 degrees, right? So is this 90 degrees, right? And then we intersect this point at B, which is equal to our this point over here. We can construct one circle, right? So I hope I've convinced you enough that all you need is 2 points to determine the exact location of the circle. Okay, so that's what we mean by the rules of the circle now. Okay, there are other rules we'll talk later when we apply, right? So over here now, so now we can find where, so I'm going to call this point over here. Okay, I'm going to call this point over here my stress A, which is one of my principal stress. Over here, I'm going to call my stress B. Okay, and this one is my stress C. Okay, no particular order, it's just random naming. So now we have to find, okay, we have to find the position right? We have to find the position of stress B, right? To determine the stress average, right? We have to do, so we know point A, we know stress A, stress B, so we need to determine the average stress, okay? But first of all, we have to determine stress B first, okay? So to determine stress B, I'm going to call this point over here, right? I'm going to have an angle over here. This angle is equal to alpha, right? So if that angle is equal to alpha, this angle will also be equal to alpha. So we're going to find tangent alpha is equal to what? 40, right? Divide by 10, 20, 30, 40, 50, 60, 70, 80. Divide by 80. So alpha, okay, so alpha is equal to 40 divided by 80 inverse tangent is equal to 26.56 degrees. Or 57 degrees. Okay, let me do it again. So 40 divided by 80 inverse tangent, okay, 26.56 degrees. So now I want to find stress beta or stress B. Sorry, I'm finding the position of stress B. So position of stress B is equal to minus 70 plus by what? So this is 40 divided by tangent 26.57. Let me see this right. Oh, no. I think this is wrong. Wait. So I need to do some side work, okay? So this is 40. This is alpha and find x. So tangent alpha is equal to x. So sorry, I got it wrong. So it's equal to 40 tangent 26.57. So this is equal to tangent 26.57, okay, times 40 minus 70 plus, so this is minus 50, okay, which is what is drawn over here also. So once you know that, you can calculate where your stress average is, okay? So your stress average, which is the center of the circle for stress A and normal stress A and normal stress B, so it's equal to minus 150 plus by minus 50 divided by 2, okay? So this is equal to minus 100. So now we know that this is our stress average. Okay. So now we can draw a line, right? We can draw a line from here to here. Okay, and then we can cut across up to here. Okay, when it intersects the shear line, you stop. And this is where our stress Y2 is. Or our Y2. I want to call it stress Y2. Okay, so this is our Y2. Right? This is our Y2. So when we have that now, right? So this is the center of our circle. right? There's the center of a circle. Now we can construct one of the mole circle now. Okay, we can construct our XY plane circle. So our XY plane circle, so it's 50. So 50. So I'm gonna go up by 50. Hold on. Where is my pen? Okay, so this is our mole circle. Okay, so this is for now. This is for your XY plane. Okay, and then the outer one, this one that we have drawn, the big one, it belongs to your YZ plane. Okay, now let's calculate stress Y. Okay, so we calculate stress Y. So stress Y2, but before we calculate stress Y2, we need to know some values first. Okay, so if we know this is alpha, right, this over here is also equal to alpha, right? And then this angle over here is equal to 2 alpha, because this angle over here is 180 minus by 2 alpha. So this angle over here is definitely equal to 2 alpha. Okay, that angle over here is equal to 2 alpha. Why that's the case? Because these two distances are the same. Okay, and that dictates the angle over here are the same, right? So over here will be 2 alpha, because the final angle over here is 180 minus 2 alpha, and then it's opposite angles, that's why it's equal to 2 alpha. Yeah, right. So we also know the radius of the circle, right? So the radius of the circle, is 50, right? So radius of the circle, so tau max for XY plane, right, is also equal to what? So if you want to calculate, will be equal to minus 150, right? Minus 50 divided by 2, right? Oh, not square bracket, because radius is absolute, so there's no positive or negative. So this will be equal to 50. Okay, so we know that it's 50. So 2 alpha, so we are going to do stress Y 2 is equal to minus 100, because the center of the circle is minus 100 now, right? We found that the average is minus 100, and it's going towards the left hand side. Okay, then it's going to be equal to 50. No, I'm not going to use. I'm going to use sine now, right? No, I can use yeah, I'm going to use sine. No, cos, because I know 2 alpha, I know my radius. So 50 cos 2 alpha. Okay, so this will be equal to minus 100 minus by 50 cos 2 alpha is 2 times by 26.57. Okay, so this will be equal to 26.57 times 2. Okay, cos times 50. So it's equal to 130 megapascal minus. Okay, so stress Y2, right, is equal to 130, right? It's about right, megapascal. Okay. Okay, so this is the answer. So if you look at the answer booklet or the answer that you see, right, they also have what? 130, right? We don't need to show this that this is okay, because we have drawn the what? We have drawn the circle, right, that is inside the operating boundary. Okay, so that circle that we're going to draw, our final circle. Okay, so this is 50, so 250. So in your exam, when you solve this problem, you have to draw all these, okay? You have to draw all the 3 circles. Okay. So this is for your X